Hi everyone, my name is Noe, and I just went to a CMG course on using their basic applications, mainly Builder and IMAX and results, and I'm going to go and convey to you what I've learned and show you all the exercise that we did. It might take a series of several YouTube videos, we'll see. Also, I'd like to thank CMG for giving the course and my instructor Tan for being awesome. So let me start showing you how we're going to go and build this model to predict some oil and gas. So first you have to open Launcher. That way you do that is you go here and you look for Launcher. Now there's several versions of my computer. We're going to be learning how to use the latest version, 2017. Exciting. So we open it up. Well, first of all, we need some data for our exercise, and I have written it down in the description of the YouTube video, so you can go there and download the data. Also, I made this folder called models right over here, and in models I put all the data that you should have also been able to download. So that's exciting. So we're going to go and start a project, and we're going to try to go and aim to find this models folder. So let's go and do that. I already actually have a project here, but I'm going to go and show you how to do it anyway. So project, add, and I'm going to go to project directory. And for me, actually, you're going to go choose it, but for me, it's already in here, correct? So it's models. I'm going to give a description, and I'm going to call it a tutorial on Builder and IMAX, and also results. How exciting! Okay, so now you have it here, and if we look at the data, we can see here in this viewer, and everything looks gorgeous. Now we're going to use Builder. But before we do so, let's just understand what we mean by build. What are we building? So we're building the data file. So if you ever used Eclipse or Tuf2 or any simulator, you'll know they usually have this data file with some keywords, and you have to figure out how to tell the simulator what you want to do. Like, what do you want to simulate? What's your model? What are the boundary conditions? Everything. So what Builder does is builds the stat file. And the stat file is what communicates to the simulator what to do. So if you take a look here at one of these DAT files, we can see definition of the grid information. Yeah, you can just imagine trying to write out all these keywords. You'd have to follow a dictionary, understand the syntax, everything, to get all these well trajectories inside. So CMG makes it so much easier by having this builder. You can just go and it will help you build that file. You don't have to go and hop around, try to figure out how things work. So we're going to go and double click on Builder. Okay, now if you've used Builder before, you'll see this error here and that amazing noise. So you can just ignore that. So we're going to make a new new model. So you're going to click on New, and here we have to choose what simulator we're going to use. So we're going to use the black oil simulator IMAX. Because we're in the United States and they're a bit behind in life, we're going to use field units instead of what everyone should be using, which is SI units. We're going to be using a single porosity, and we're going to set the simulation start date to 2016. And that is because we're going to be importing some data that is time-stamped, like production data, and you better have the year right, otherwise, yeah, there will be problems. So we open it up, and what we see here on the left is we have the I/O control, reservoir components, rock fluid. This is basically your workflow. You go, you make your model, you're going to fill out each one of these tabs one at a time. Once you get a check on each one of these tabs, you're done. That's it. So that's what our goal is, to go through all of these and make them turn green. And then you'll be able to run the model. So that's what we're trying to do. So I/O control is already green, so you don't theoretically have to do anything. But I'll just show you what you could have done if you wanted to. So for example, I/O, which is input-output, you could change the simulation results output. For example, you could change the frequency of the results writing file for the different types of information regarding the wells, information regarding the grid properties, the information regarding the sector properties, And all these will have a big impact on how big your results file is. So if you're doing bajillion runs, maybe it would be better to not have that many things that are being output. Or if you have a huge, ginormous model. So for example, here you can also see what items that you're going to be outputting. So if you look here, for example, the grid items, you can select the grid variables that will be outputting at every time step. So you can see the bubble point pressure, the oil potential pressure, this water saturation, important to know, aquifer water influx, so that's good. We're not going to actually change anything, I'm just showing you what's going on here. Okay, perfect. So now it is time to go and build a grid. And the way we're going to do it is first we're going to import this map with contour lines, and then we're going to build our grid based on those contours. And these are contours at the top of our reservoir. So I'm going to go into File, and then open that file. And we're going to be using the Atlas boundary format. And I'm going to open a file, and I'm going to go into my data, and I have this depth to top of surface. And I'm going to open that up and press OK. Wow, and look at this. We already see this amazing contour file. Perfect. Now let us go and build the grid that will go around this contour file. Actually, also one last thing. Notice the fault here? That's pretty cool. We already got a fault in the system. Also, if you're asking yourself, what does this file look like? Let's just take a quick look at this file. What does it look like inside? Maybe you could one day want to make one of these on your own. Not something too okay, so we're going to try to find our notepad, and there we go. Let's take a look at it. So what we can see here, for example, is contour, and then we see what the depth is. And now another thing to note is that CMG 0 is like 0 at sea level, and 10,000 is 10,000 down, not 10,000 feet up. Okay, so this is downwards counting. And how many points do you have? 70. And then here's listing just those XYs, those circles of the contours. And then, so you could see yourself, if you're good at coding, just making these contours on your own in MATLAB or something. And then also you can see here the fault, and you can see its depth, and it's only one down, and how many points are defining this fault. That's cool. Let us continue. Okay, so now we have these contour lines. Well, now we need to build a grid, right? So let's go to Reservoir, and we're going to create grid. And what we're going to do is orthogonal corner point. Now we need to decide how many grid blocks do we want in every direction. So we are going to decide on that number. One moment. Dum, 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 dum. Okay, so we're going to decide on I direction 27, and then 45 in the J direction. And just to make clarify, we're on the same page. I is this direction, J is that direction, and inwards and down is the K direction. So we're going to have 4 layers in the vertical direction. Now, there is a possibility here that you go and you just give 27 numbers with the block width of every block. So you could be like, oh, first block is 100 feet, second block 200 feet, the third block 400 feet, next one 220, okay? But that's tedious, right? You have to write 27 numbers, that's a bit much. If all of your blocks are the same length, you can just go 27, that's the number of blocks that you have, and then times the width of the block, so 27 times 100. So in the I direction, you're going to have 27 blocks, 300 feet wide each, okay? And then the J direction, we're going to do the same thing, 45 times 300 feet wide in the J direction. Perfect. Okay, let's do it. I got the grid. But oh no, look at it. The grid is not aligned exactly on all of our contours. So what are we going to do? We're going to click on Shift, and we're going to try to move it upwards. But unfortunately, it's not working. Oh, there we go. It is working, and now to the best of your ability. Mine's limited on my small screen, but try to get the whole contour lines inside of your grid. Oh, that will be enough for me. And that's it. Look at this. We've got the grid gorgeously aligning on top of our contours. Okay, so right now we're going to go into probe mode. Now, sometimes you can be like, well, why aren't any of the buttons working? So a lot of times, if you click certain buttons, you'll see that certain other buttons gray out, especially here. So for example, specified property was not working, was grayed out before because I wasn't pressing on probe mode. So a lot of times, if we just press on probe mode, a lot of good things will happen. So we just did that, and now we're going to press on specified property. Okay, now grid top can be a little bit confusing. So what you could do here is you could say, for example, the top of layer 1 is at 10,000 feet down. Top of layer 2 is at 10,500 feet down. And you can give each one a number. On the other hand, you can just give only the grid top for one of the layers, and then the grid thickness for all the layers here, and then it will on its own figure out what is the grid top for each one of the layers. And it will also be spatially varying. So what we're going to do here is we're going to go to layer 1, and we're going to right click, and we're going to click and choose geological map. So we're going to use a contour map, values in file 1. Now we're going to open the same exact file that we used previously, which is the depth to the top surface. And we're going to click on OK, and we're going to keep it ×1. We're not going to change any of the values, and OK. Perfect. Now, like I was saying before, you can go into grid thickness, and here we're going to tell the software what should be the grid thickness of every layer. So again, we have a map, so we're going to go into geological map, and we're going to choose values in a file, and now we're going to choose this grid thickness. There we go. But now this is the gross thickness. That means the thickness of the whole section. So we have 4 layers. So we're actually going to time the gross thickness by 0.25, 1/4, so that every layer will only have 1/4 of the total gross thickness. Now I'm going to go and press on Control-C and highlight these. Click on Control-V for pasting. Ta-da! I'm done with grid thickness. Now I'm going to move on to porosity. And porosity, we also have a map, so I'm going to right click and click on geological map, and I take values in file 1 and going here, and we have a porosity map. So that is great, and click on OK, on OK. I'm going to right Control-C and then Control-V over here, and suddenly I have all of porosity, and that is just gorgeous. So I'm going to go and click on OK. But now it's going to ask me, you're importing these values. How would you like to interpolate them onto the map? I'm just going to keep all the defaults and click on OK. While something exciting is happening, bam, bam, look at this. We are looking right now on the grid thickness. That's nice. We can also look at porosity, which we just imported, LMNOP right there, porosity. Look at this nice porosity field, a lot of porosity here at this high point over there, and we can scroll and look at the different layers and look at the different porosity. It happens to be the same porosity for every layer, but maybe if you had a different map for every layer, you could have a more variable porosity. So how does this look in 3D? 3D is so much cooler than 2D, right? So we're going to look at it in 3D, and we're going to click on this guy here, this hand, move it around, move it up and down, I guess. And we're going to go and click right here. I'm going to turn it around a bit. And oh, look at this. It is amazing. Very 3D. Now, because this little reservoir is not an angel, we don't want to see his contour lines like a halo or something. We're going to go into properties. And then we're going to go into map. It should be somewhere here. There we go. Maps. We're going to go right here. And then instead of being just above the grid, because come on, that looks ridiculous, we're going to go to true depth of contour surface. Much better. Oh, look at that. Everything is looking beautiful. And while we're at it, let's just remember to save. Saving is just a wonderful thing to do in life, always. Oh, but I didn't give this thing a good name, so let me save as, actually. Well, let us call it, instead of CMG Builder, we'll call it Best Reservoir on Planet. Yeah, that's what we're talking about, guys. Okay, nice, we are all saved. But as you can see, we are still missing some properties, right? We're all for getting this X away. What are we missing? So let's go down. We're we're missing the permeability. Now, we don't have permeability because those damn geologists, just the nice geologists, didn't give it to us. So what we're going to do is we're going to go and use some sort of formula to calculate this permeability from the porosity, which is a sketchy thing to do, but when one is desperate, and this is just an exercise, there's nothing that you can do. So we're going to go to Tools, and we're going to go into Formula Manager. Now we're going to make a new formula. I'm going to call it perm from pore, in case any future person wants to know what to do. Then we're going to add a certain property, let's say porosity, because that's what we want to use. And this variable is now called XO, and now we put in the formula for getting the perm from pore. Now this formula, I am not sure what the secret source of it is, but here it is, guys. This is what we're using just for the exercise. 5 times exponent of 20 times x0. Perfect. We have a formula. We're going to click on Apply. It's going to make some noise, and then on OK. Well, we have the formula. So let's go back to Specify Property. And let's scroll over to Permeability in the I direction. Now, for the whole grid, we're just going to use this formula. So we can go here to Formula, and from Formula, and man, look, we have perm from pore. Look at that. Let's click on it, and it's there. We got it. We specified the permeability in the I direction. Now let's go to J, and we can go and make the J equal to I. That means permeability in both horizontal directions are equal. How about the permeability in the K, as in the vertical direction? Now, you all might know the permeability in the vertical direction usually tends to be a little bit lower than the permeability in the horizontal direction. So what you can do here is we're going to click on equals I. Don't get all stressed out. What we can do is equals I times 0.1, meaning it's going to be 1/10 of the permeability in the horizontal direction. And I click on OK. I'm going to import this into my model, so I'm going to click on OK again. Guys, we're getting very close. It's not a V, it's not green yet, but it's a warning sign. So let's see what else we're missing. And that is the rock compressibility. Okay, so let's give this rock compressibility so that we can continue and strike that positive green V mark. So we're going to put in 2e to the -6, 1 over psi, and then in terms of the reference pressure, we're going to put in 4,900 psi. Wow, did you see that? It just turned green. Now, just one little thing I'll show you, even though it is not necessary for this example, but it's possible to make different zones for the compressibility. The way we can do that is we're going to go and scroll down here to compaction dilation regions. And I'm going to create a rock compaction region, a new region. Let's say, well, for now we're just going to give it the same properties as before, but you could put here something else. 2e to the -6 and 4,900. I'm going to click OK. And now I have a compaction dilation region. Now we're not going to do it for here, but what you could have done is, I'm pretty sure there's somewhere over here where it's going to say rock compaction set number. And then you could assign different compaction dilation regions in your area in case there's different compressibilities in your different layers. Okay? You could have put here layer rock type 1, here rock type 2. Could have created more compaction dilation regions. Okay, so I think we got the IO control and the reservoir down. I think it's time for me to take a break. So I will continue it in the next YouTube video. I hope you guys are excited and waiting. And good luck.